Tervetuloa tähän Senergia järjestämään webinaari, jossa käsitellään teollisen kokoluokan akustoratkaisuita. Ja oikeastaan meillä on nyt tänään päätuotteena Luna 100-200 kilowattitunnin ratkaisu. Ja meillä on täällä mukana meidän yhteistyökumppanin Photomateiltä niin Faisal ja Rafal. Ja he on nyt ollut käyttöön ottamassa aika montaa näitä Luna-akustoa tässä viimeisten viikkojen aikana. Heillä on aika hyvä tietotaito siitä, että mitä tuommoinen isomman kokoluokan akusto tarvii siinä käyttöönotossa, mitä tulee huomioida asennuksessa ja mitä kaikkea se sisältää. Ja tosiaan tämä Photomaten osuus pidetään englanniksi ja vaihdankin kielen tässä saman tien nyt sitten. So, welcome Faisal and Rafal, and you can present yourself, and I briefly inform that you are from Photomate, and you have now commissioning quite of many these Luna batteries during last couple of weeks, so you have good experience for what is the inside light of these batteries. But you can start the presentation and
yes,
let the participant to know what is inside of the Luna.
Yeah, thank you, Kalle, for giving us this opportunity to holding this webinar. My name is Faisal, and I'm working as Solutions Manager based in Stockholm, Sweden. And with me, I have my technical head engineer, Rafal, who's sitting in Poland. So yes, today we will focus, as Kalle started, we will start talking about the topics of CNI batteries. So, and if there is any questions during the presentations, please feel free to ask. We can have it as more like a communication dialogue. It shouldn't be a straightforward presentations. I think more dialogue and having questions during the presentation, that will be more efficient. So if I may, I can start, Rafal.
Can I interrupt that way that tosiaan, jos tulee kysymyksiä, niin voitte laittaa ne tuonne chattiin, vaikka ihan suomen kielellä, niin sitten saadaan ne sieltä esitettyä eteenpäin. Niin rohkeasti vaan kysymyksiä ja keskustelua, jos siitä tulee.
Yes.
Yeah, you can continue.
Rafal, would you like to present yourself?
I think you have presented me very well, so thank you for that. I'll be just today the support for Faisal in terms of some questions related to this product, so I'll just leave the microphone to Faisal. And then, of course, if you will have any questions, you can leave them on chat or you can just ask them directly. I'm pretty much sure we'll try to answer all of them accordingly.
Perfect. Okay, let me start. And just some quick words about the background of ancillary services. And also we'll try to highlight how is the situation in Sweden. Since we don't have such a stable grid system in Sweden, so the service for balancing the grid is, the potential for it is very high in Sweden. We know that especially when we have introduction of renewable energy into our grid system, since renewable energy is not always constant, whether it be wind farms or it is a PV generation, it always destabilizes the grid because the consumptions and the demand, the production doesn't match each other all the time. In that regard, the frequency on the grid will be disrupted, and that could be a very big issue for the grid operators. So that's why the more renewable energy we introduce into our grid system, the more need will be there for the frequency regulation of the grid. So that's the main point behind the frequency regulations and the grid stabilizations. And that's why we need the energy storage system to do this work for us. So what's in our portfolio for CNI? This is the general architecture and the product portfolio which we have at the moment for CNI solutions. We have optimizers which are specifically designed for the CNI system for industrial scale projects. If we have like a big PV plant park, then we also have our almost new battery 115 KTL M2 400 kVA CNI inverter. And in the middle, this is the most important battery, or the very important product that we are working with right now in Sweden. This is the Luna 2000 from 93 to 200 kilowatt hours storage. And this, we will go into the details how it can help to stabilize the grid. Then in future, we will also have other products like a bigger power unit, liquid cooled power units. And these are the roadmap and later on for Huawei. And of course, we have a management system. We have a server which is getting every day more smarter and more practical in order to monitor and maintain the whole CNI project, whether it be the battery or the inverters. What can we use this battery for? Of course, it has different business working models. It could be used as maximum self-consumptions. For instance, if there's overproduction, it could be stored in our battery, or it could be used for the FFR, fast frequency response, or frequency up or down for the grid. And also we could charge and discharge according to the cheap price on the electricity, or it could also use as a peak shaving to reduce the extra cost for those peak hours for some industries, especially if there's production industries. So depending on what models we are using, also the return of investment of this product depends on that. For instance, for frequency market right now, the return of investment for this product is very low. We consider more or less it'd be below one year. So depending on what model, how the battery is used, also the return of investment, the payback time for the battery varies. And this is our initial test we did in Sweden to see if the battery could qualify for the frequency market.
Faisal,
yes.
I have a question regarding that. If you go one slide back, what for these 5 business models are included in this Luna's own software, and what needs some like third-party solution?
Of course, we will go into the details a bit later. But for example, for frequency, we need EMS system, a third-party EMS control system. For example, in Sweden, we are using Checkwatt, and it comes both as a software and a hardware part from Checkwatt, which must be included in order to make this battery work for frequency. But for other models, for example, maximum self-consumption, time of use, then we need, of course, a power meter to analyze the power on the grid connection point. And according to that, the battery will charge and discharge.
But those functions Huawei can provide and no third party needed.
Yes, of course. Maximum self-consumption, time of use, peak shaving, these are the services that Huawei can provide it already. But later on, we will also have, exactly, but nevertheless, we need EMS system, for example, to use for FFR services.
Okay.
We could also need EMS system to control, depending on different configuration of our project. If there's PV panels which are not compatible with our system, then we need an extra unit control system for third party to control the PV side and the energy storage side.
Okay. But thank you for clearing, and you can continue.
No worries. So let's see. Exactly. This is so our initial test, and it has qualified with CheckVatt with the aggregators in Sweden. So our battery can respond fast enough to stabilize the grid for frequency. So now we are behind this pilot test procedure. We already qualified all these battery models. It comes in different capacities, and all these capacities are qualified for the frequency services with our aggregators CheckVatt. But of course, we have other aggregators in Sweden. It's not CheckVatt. There's Flower there, and all the time there comes more and more aggregators into the market. Just here is some data from the last year when it came to frequency service and the prices which the customer got for this Luna battery. And we can see that especially during the summer, when there's too much production, at the same time, the grid will be more demanding to be stabilized on frequency side to bring down the frequency in the grid. And last year we could have a return of investment approximately 8 months for this battery. But of course, in Finland, Kalle knows more about this market, how was the energy prices, but I would say it is a similar pattern when it comes to the prices for the frequency market. So yeah, let's look into a bit hardware of this battery. This battery is coming and not assembled in all parts. The only thing which comes is the cabinet, and the rest of the and also the AC units, the air conditioner, these are already attached, and the cabling which goes on the PCS side and the rack control. These are prefabricated and pre-mounted. But the rest, we have to assemble it ourselves. On the left side, we see we have a PCS. This is an inverter actually, with a AC and DC side. And on the right side, the number 4, this is the DC rack controller, and it is controlling how the modules inside the cabinet should be charged and discharged, and maintaining or controlling the sock of the battery modules. Inside the cabinet, we have the storage itself, the modules itself, which stores energy, approximately 16 kilowatt-hour per modules. In one cabinet, at maximum, we can have 12 of these modules. And these modules should be assembled after we have put this container on the foundation at customer sites. And of course, there are a lot of communications line going between the modules, and also the copper bars between the modules. All these should be assembled at the last stage once the modules are inserted inside the battery. It's quite heavy. Even the modules are very quite heavy at weight approximately 140 kg. And that's why we need also a forklift to lift up these batteries and insert it into the cabinet. It's important, especially for frequency market in Sweden, that the ancillary aggregator service, they always want to have your battery ready for 100% of the time. And this, if you cannot provide them 100% of the time your battery, if you cannot, for it, sort of say to rent the battery, then they cannot give you this. Then the price also changes. So it's important to have a battery system which runs all the time. And so this is one of this specification for our batteries, that the whole idea and the whole science behind it, that it should be run all the time and it will self-maintain itself, and every upgrade, everything will be done automatically from our server. No manual working to maintain the system. So this is one of these things which is important with battery, that it's the idea is that it's 100% of time available for the customer. Let's talk about different capacity. I think we already mentioned it a couple of times before in Finland. that this cabinet comes into 4 different capacity. The smallest capacity consists of 6 modules. The maximum is 12 module battery. Basically, the first 3 capacity are exactly the same when it comes to the wiring, the cable size, but the 12 modules, it has a different cable and different internal parts. But the first 3 modules, they're exactly the same. Depending on what capacity we have, the ratio between charging, discharging, and the capacity itself, storage capacity, could vary. For example, for 96 kilowatt hour, we have a maximum 1C value, and this is the highest rate for charge and discharge. And this C value decreases when we increase the capacity of the battery, when we go from 96 to 193 kilowatt hour. So in Sweden, for instance, Checkvat is expecting that the battery should have 1C. And this is also why a lot of customers in Sweden buy this capacity with 6 modules. But of course, you can connect in the same system. You can connect different cabinet with different capacity, but the total system C value will be the one which is the lowest. One more thing that I have to mention, that even if these batteries are exactly identical when it comes to the hardware, especially the first 3, but we cannot put more modules, like say in 1 year, to just increase the capacity at the moment, at least, because each cabinet is pre-programmed for specifically those amount of modules. If it's 6 modules, it's programmed for 6 modules, and so on. If it's 8, for 8. But of course, we have this discussion with Huawei that we will see the possibility for future if we can increase the amount of modules. Say we start with 6 modules and we have chosen a certain business model, but now our business model, the project idea has changed. We want to extend the modules. We should be able to do this. But this is something that we have discussed it with Huawei as Photomed, and also this discussion is still ongoing. So, but just keep in mind, because some of our customers are already asking us these questions, whether they can put more modules like later on. But at the moment, this answer is no.
But you mentioned that it's not possible to increase the model, but of course, if when the lifespan of the existing battery models, you can replace those.
You can replace
in
those
the same amount.
Yes, but the CMU unit or the whole control system unit is programmed for those number of modules. If it's 6 modules, programmed for 6. But of course, if one of those modules said it's defected or needs to be changed, you can do it. But you can never, at the moment, you cannot just put from 6 to 8 modules. You cannot just put 2 extra modules. But it's an interesting point. Our customers want to have this option. So that's why I said that this is an ongoing discussion with Huawei, how it will be in future. So there's a closer picture of the battery cabinet, especially for those who haven't seen it before. We have on the right side, we have the finished products assembled, the modules, the copper bars, and also we have the power distributions unit on the right side, down on the right side. This is the power distributions unit, where we can even our CMU, like the brain of the cabinet, is placed there. Then we have different sensors for humidity, for temperature, and also sensors for the doors. Everything is attached, and those are pre-installed in the cabinet. The sensors, most of the wirings are already on the cabinet from the fabric. And even the power distribution unit is there, but of course we have to make the connections between the PCS and DC rack controller on the bus side, on this inside the power distributions unit. but the modules and the copper bars and the communication between, these are the ones that we have to ourselves assemble. And it's also important to mention, for instance, that there's a sensors on the door. If the level on the ground is not level, the battery door shall not open, and this is a safety issue. So there's a lot of sensors already built in and pre-installed in the battery. Here's a more closer picture of different sensors, different part of this battery. When it comes to the installations, it's important to keep in mind some small details, especially when it comes to how you have to install the PCU and also the fire extinguisher unit, which just goes on top of it. And this is important that you have to make right measurements, so the fire extinguisher shouldn't sort of say that it should be a reliable source when it's like said when there is a fire or smoke inside the battery, so it should be able to operate. So that's why when we do installations, when we do our supervisions, when we are on site, so we make sure that this fire system and works, functions as it should before we start up the system. And also we recommend that the PCU, which is just on the where my mouse is going, the PCU should be installed very cautiously, and also maybe at the last step, once the modules, everything is installed, the PCU should be installed at the last step in order to not damage the PCU, and also it's recommended the last step. So just now a bit on the configurations, what kind of project design we have, what kind of how it looks when it comes to the applications of ASS, this energy storage system. Before we started with the presentation, me and Kalle, we talked about some of the component which is not so clear in the manual maybe, but this is what we are going to explain. What are those components which could be actually replaced by other component, cheaper component. For instance, smart loggers or SACU, this one unit which we could actually, we go inside, we will show you what is inside SACU, but we will also give you alternative if we can replace SACU with just smart logger and some switches or smart model. But nevertheless, let's look at the general configuration when we have a system.
Yeah, but just for like clearing, SACU or smart locker, they are used for communication between the Luna batteries, and of course in this configuration with inverter also.
Exactly, we will go into more details a bit later in the presentation.
Yes.
Good point. So yeah, so this is the general configuration. So say we have PV, we have a PV system, inverters, and also we have energy storage system. So this is how we can connect it on the, and we have one grid connection point, 400 volt. This is the simplest configurations. And we can even put up to 30 inverters in such a system, CNI inverters. And the model and specific model of those inverters are M3, V5, and V+5. And these inverters could be used even for off-grid. And also we don't need any extra component such as isolations transformer. But if you're using non-compatible inverter, for instance, in such a system, it could be like Huawei's inverter, which are not listed, or maybe other brands. Then in that case, we might need also have isolations transformer between the inverters and the ASS. And this is partially a reason for the cross current resonance current which builds up between the two systems. In order to avoid that, then we need an isolation transformer. So for the compatible inverters, for on-grid, especially on-grid, if we want the whole system to be connected to the grid all the time, we don't need any isolation transformer. So there's more specific details of what inverters could be connected with our energy storage system without needing any isolation transformer. And also some specifications, for instance, the distance between the PV inverters and the AC distribution box, and what should be the length of the cables between the PCSS and the distribution box. So this is the white list of those inverters which are compatible with our system. But of course, we can use non-compatible inverters, but then we need isolation transformer. So here is a system without PV inverters. So just we have a 400-volt connections point. We have a SACU or smart logger, which controls the energy storage. So this is sort of, say, the brain of the system, sends the command. And also it sends the information back to Fusion Solar to the server. And this is important that we recommend that the customers connect their system to Fusion Solar server. This is also one of the conditions for the warranty. If we want to have extended warranty from 5 years to 10 years, then it's mandatory to connect it to the PVMS, to the server, Fusion Solar server. So that's also one of the job of the SACU, to send all the information from ASS, apart from controlling them, to send the information to our server. Yes, then we also have some scenarios where we have non-compatible inverters and we have 2 transformers. So this also practically, it is also allowed, this kind of system. Then we have 2 transformers sitting, one on the PV side, one sitting on the ASS side. And the configuration of it could be either solutions 1 or solutions 2. But in this case, we need 1 extra smart logger, which is connected, which controls the PV inverters. The second smart logger or SACU controls the ASS side of the project. And these 2 smart loggers or SACU further connected to a third-party control system, which will be the ultimate control unit. And this control system should be able to do some extra functions to the system, sending extra commands, for instance, to make it on-grid, off-grid command. So this third-party control unit should have some kind of specifications in order to work for such a system. We will go into the specifications later on.
Question regarding this solution now. For example, now here in this solution number 2, so if there is like existing PV system on site, and it's, for example, use some other brand's inverter in that case, or Huawei inverter, what is not compatible with the.
Yes.
So in that case, there must be installed this step-up transformer, which is like a isolation transformer.
Yes, exactly. To prevent the cross current of the parallel system. That's one of the reasons. But also, it's important, for instance, if the system, the grid collapse, and we still want to run the energy storage to provide energy to our industry, for example, since the inverter, the PCS is asymmetrical power, so then the load might be unbalanced. So it's also important after isolation transformer. That's also one of the reasons. But of course, if you have just let's think of the system which is not compatible inverter and grid connected. In that case, it's also mandatory to have a step-up or isolations transformer to separate the two systems. So yes, so this is a condition when you have non-compatible or other brands inverters that you have an isolations transformer. But isolations transformer has also other functions or other benefits. For instance, if the grids collapse, the inverter will work efficient if the load is unbalanced. The isolation transformer will separate the inverter, the PCS which is sitting on the Luna battery from the load. Would you like to add something here, Rafael?
No, it's quite clear. Just one remark from my side is that in some competitors' solutions, this kind of a transformers is usually built inside the battery. However, we offer this without the transformer in case you do not need it because you don't care about the unbalanced loads or off-grid scenario or compatibility with third-party inverters. It's not mandatory to have it.
Yes. Is it clear, Skala?
Yeah, so it's recommended, but it's not needed if you are not considered about the unbalanced load. Did I understood that correctly now? What Rafael said, that
Yes,
it's
exactly. It's because our inverters, if you analyze the circuit diagram, it has only three-phase wires and the PE wire. There is no neutral wire into this inverter because it's not needed. Our inverters are the symmetrical source of power, so the neutral wire is useless in such a case. And if we use our battery in such a scenario where we use only balanced charging or discharging, of course, it depends on the business model we use. We don't need this transformer. Also, if we don't use it together with the third-party PV systems like the other brands, we don't need this transformer. And as well, if we don't need the off-grid mode, which in our case is mandatory to the battery to be equipped with extra EMS system, not just the transformer, you also do not need this transformer. So this is kind of a flexibility which does not force the user to buy the part or component which is not very cheap. However, it's not mandatory in every scenario.
okay. That was good clearance about that. So
Yes, and I hope everyone also understood what is discussed here. Otherwise, Kalle can shortly summarize it in Finnish if it's needed for this important point.
niin siis tosiaan voin sen, miten tämän itse nyt ymmärsin, niin tosiaan se, että jos siellä on käytössä tämmöinen inverteri, joka ei ole sopiva, niin siinä on niin suositeltava laittaa tuommoinen eristysmuuntaja, mutta se ei ole pakollinen siellä järjestelmässä, eli se on vain käytännössä yksi kallis komponentti, mutta se, että sieltä jää joitakin ominaisuuksia sitten pois, jos ei siitä laita. Mutta niin kuin ymmärsin, niin ei ole niin sanotusti pakollinen, eli jos on joku olemassa oleva kohde, niin ei sinne välttämättä tarvitse sitten laittaa tuota erillistä muuntajaa, mikä on varmasti merkittävä kustannuserä sitten siinä vaiheessa, jos se pitäisi sinne asentaa. You can continue now.
Perfect. Yeah, this is just an example of the connecting, for instance, 5 ESS containers. They are not connected parallel through the DC bus, but this one setup, and we have also the AC distribution box with the recommended circuit breaker for each PCS. We can also show that this is, for example, for such a system, what is included, what should be prepared by the customer. For instance, we have 5 ESS containers. This is from Huawei product, of course. The PCS, the inverters, which are sitting on the side of the container, is also included. SACU is also provided by Huawei. but the rest should be purchased. For example, the AC power cable between the PCS and DC low voltage panel. It could be prepared by customer themselves, and also the auxiliary power cable between the DC low voltage and the smart string, the auxiliary power which goes into the distribution box, this energy storage distribution unit.
Can you go one slide back? In this case, so basically, if there is like a 100 kilowatt unit, so you recommend that there is like 2.5 amp fuses in those.
Yes, the PCSs will have a discharge apparent power of 120 kVA at maximum and short periods. But in that case, for that, we have 173.4 amps breaker in the data sheet. But of course, if you want to limit it to only 100 per kilowatt and not exceed to 120 amps for 400 volt, then we can have a 155 amps breaker. But of course, we have to have some margin for the, you have to take into consideration the short circuit current. But of course, 250 amps is moderately recommended breaker for one PCS.
Okay, but you can use 155 also if you like limit that.
Yes, 155, it could still work for 100 kilowatt. But in the manual state for 400 volt, you will have some short time that the PCS will have a 120 kVA. And for that, it's recommended 173 as maximum circuit breaker capacity. But
I just would like to add maybe some more information about it. It's just a recommendation from manufacturer. Whatever the circuit breaker, I mean this main circuit breaker, it will be adjusted by designer, must include also such informations like what is the cable length, so what would be our line impedance in our case, what would be the thickness of the wires, and all of those let's say values supposed to be included into designing or picking right circuit breaker. It's quite popular and usual that we just check it in the manual and just they use the circuit breaker which was suggested by the manufacturer. However, please remember you always must include your electrical diagram and all the components which are in your grid and how they can affect each other.
Yeah, and of course, I think also one good thing to mention in this case is that because you are putting battery, and also the same thing, it's when you put the PV system, is that the what is the name current for those electrical cabins, what you are will connecting to battery solutions. So if the supply cable is used all the current what is labeled to the cabin, so then you cannot connect batteries also there. So it's important to notice that also.
yes. Yeah. So for that system, these are the parts that included from Huawei side: the battery, the container, the PCS inverter, and smart lateral cycle. But the cable, AC power cable from the PCS to the distribution box, and also the auxiliary system and the power cables, it should be prepared by the customers. We have a three-phase meters for analyzing the self-consumptions of the auxiliary units inside the battery on the power distribution box. That's not mandatory whether you want to install it or not. It's just for analyzing the self-consumptions of the battery for the air conditioner and other units. So yeah, here we have a situation when it is when we supply for off-grid scenario. If we want to still keep our system running, then we need to have a stable power supply for those auxiliary system inside the battery. Otherwise, when there's off-grid, when the grid collapse, then there's no power to run, for instance, the air conditioner or the CMU unit or the smart logger or even the third-party controller. Everything needs power. So for that, for off-grid scenario, if there's such scenario, then we need to have UPS, and it's a power supply, stable power supply. And also to mention that for the off-grid scenario, the third-party inverters cannot be supported. Yeah, and let's just go through this picture again. The third-party controller will also be connected to SACU, to a smart logger, and to all other units. For instance, the meter, everything will be connected to the smart logger or SACU, then everything will be controlled by the third-party controller in such system. And the power for the whole unit, external unit, and also the units inside the battery, which need auxiliary system, will be supplied by UPS. We have recommendations for what type of UPS we need, what capacity. We can show it later on. So just a general sum up of what we could use for such a system. For instance, we can parallel connect up to 20 ESS with only one SACU or smart logger is enough to connect 20 ESS together in a such system. And also if we have inverters, which are Huawei's inverters. In case we need isolation transformer, then this is the recommended isolation transformer, the Victor Group 11 and 400 volt on the two sides of a transformer. Meter is also provided by Huawei, DTSU, for self-consumptions analysis of the system. UPS is a third-party product, but we have recommendations. Even isolation transformers, a third-party product. IMD, we might talk about IMD too, why we need IMD as for insulation monitoring device. It's important to have this device, especially for off-grid scenario. Otherwise, we need to restart the PCS manually. We have to restart it every 24 hours to check to run this insulation's resistance on the PCS side, on the AC side. Otherwise, we need to manually restart the PCS every day. So that's why it's needed IMD to make this work automatically. And also not to, because during this insulation resistance, the system, the PCS will not produce any power. It could be from 1 to 2 minutes. And that in Sweden, for instance, we have calculated that it could mean a loss of revenue of 4% when it comes to the frequency services. So not having an IMD, of course, you can choose whether you want to restart the PCS yourself automatically every 24 hours, or you want to have an IMD which can do this job automatically itself. So is there anything you want to add here, Rafael, about IMD?
No, everything was said quite clearly. Just please do not mismatch the existing of IMD system with the IT system of the grid. It does not refer to it. The IMD is here to protect the circuit between the ESS and isolation transformer due to the electrical shock protection. And this is the main purpose of it.
Great. Yeah, and of course, we can have pure off-grid system, and even there we need IMD to make to measure the insulation resistance between isolation transformer and energy storage. We could have diesel generator as a reserve power. As a reserve power, whenever the battery has low SOC, the diesel generator can supply power either to the load or charge the batteries. Still the same setup as before. What could be included in such a system decides what are in Huawei's portfolio, what are the third-party products. For example, diesel generators also a third-party system. The microgrid control units also could be a third-party system, like AMS, like CheckVatt we have in Sweden. And exactly the same isolation transformer, UPS, these are the products which customer need to buy from other vendors according to their needs. So yes, exactly the same as previous when we have before we had the power grid, but now if you want to run it totally as off grid, of course we can use our battery system to use it as pure off grid. Diesel generator could be also alternative options, like optional if you want to have it in order to have power all the time when there's lower SOC in the batteries that can discharge was load. So this is exactly the idea behind having an IMD, especially for off-grid system or when the grid collapse. In order to not make the PCS restart manually, we can connect the IMD to make the insulation resistance test. And every time if there is some low insulation resistance, this IMD unit will send information to the smart logger or to SACO, and it will generate an alarm if there is any problem. For the on-grid system, the PCS automatically every 24 hours, from 1 to 2 minutes, it runs its isolation resistance test. But for off-grid, it's important to have IMD. So there is some requirements of isolation transformer, the capacity. We need 100 kVA transformer for each cabinet PCS. So there are several PCS, says several cabinet. We just multiply from 100 kVA up to 120 kVA per cabinet, the total capacity of the isolation transformer. And some other specifications, the transformer ratio should be 400 to 400 volt, 3-phase. And the vector group should be 11. The PCS is connected to the delta side. Then we have some other specifications which could be taken into account when we purchase isolation transformer. Here's also some recommendations of use UPS and also the capacity for UPS. For instance, if you have 1 to 2 UPS to ASS container, so the total supply power we would need is from 1 to 2 kVA. And if we go from 6 to 20 ASS connected to the same system, then the total power should be 3 kVA to have a continuous supply of power. And also 220 volt power supply. So just about communications, because that's also from my experience in Sweden, one of the questions we get a lot about the communications. So what are needed for one ASS, and if we have one battery, if we have 5 battery, what could be included in the project, what could be eliminated. For instance, if we have a very basic system, say that it's only ASS, we can connect up to 20 ESS to one SACU smart logger. And this SACU actually, it contains one smart logger 3000 and smart module, apart from other safety SPD switches. But the main thing is that we need smart logger and smart module to connect to communicate with our system. So SACU could be optional to buy it as a whole. We can always just use a smart logger or a smart module and switches to replace SACU. It's very possible. So the system communication design. The PCS also has a communications line, FE communications line, which goes from PCS to the smart module. Later on, I will show a picture of smart module for those who haven't seen it. But it's just an extension of the switches, the input switches, as lane switches. So here we have SACU. Inside SACU, we have a smart logger 3000 and an extension switch called smart module. So the PCS will be connected directly to the LIN on the smart module. Then also the CMU unit, there's a smart logger inside the ASS. We call it CMU, control monitoring unit, sitting inside the cabinet and the power distributions box. So this smart logger will also communicate to the smart module. And from smart module, we will have communication to the smart logger. And of course, from smart logger on the VEN input, we can communicate to Fusion Solar Server. So there's two communications line going out from the ASS battery, one from the PCS on the inverter, one from the CMU unit sitting inside the battery. And here are some specifications about the distances, for instance, the Ethernet distance from the PCS or from the CMU unit to the smart module. So the recommended is that it should be, if it is 100 meter. So if it's not more than 100 meter, then also perhaps, for instance, if we have inverters, we could use M-bus communication if it's more than 100 meter. We can connect furthermore if we have a smart meters, if we have PV inverters, exactly as we do in ordinary installations, that the inverter either can communicate with Modbus RTU communications line to the smart logger COM ports, or it could, if this inverter, PV inverter, has the options to communicate through the power line M-bus, we could also communicate to the inverter, to the smart logger through the M-bus communication. So it's very flexible how other units are connected, either by Modbus RTU, for instance, for the meter, RS485. If it's inverter, it could use RS4852 or M-bus communication if it has the alternative for M-bus communication. But let's say when there's more ESS, more cabinets connected in parallel, for instance, from 2 to 4 ESS, then still we have SACU, but keep it in mind that you don't need SACU itself. You could use just smart logger and smart module, but you need a 5-port switch, this extension switch. Then the PCSs that are connected in between each other in the cabinet, and the first and the last PCS are connected to the LAN port of the smart module. So this is a star and ring communication system. Still, we need to connect every CMU sitting inside the ASS to the 5-port switch as before. So this 5-port switch is just an extension to just increase the inputs on the smart model, since we only have 4 inputs. But from our experience, when we have one ASS, of course, we can use just one connection to the LAN. But to have more stable communication, we can recommend, actually, from our experience, to use 2 double communication line, because there is double input for FE under the PCS. We could use both communication, both these two connections and connect it to the lane. For that, we will have more stable communication. We have observed it from other projects. But of course, in the manual, this is the general rules from the manual. But in practice, you could actually, you can draw one more line from the PCS to the lane to have more stable communication, especially if it's only one ESS. But nevertheless, so if we have more from 2 to 4 ESS, then we need a 5-port electrical switch. And also the specification for switch is written in the manual, what kind of switch it should be. And this switch will be just an extended lane ports to make the whole connections possible between the ESS containers. Of course, we have also fiber communications if we don't want to use let's say fiber ring network. If we don't want to use the communications through the Ethernet, we could use the fiber input on the ASS on the CMU unit inside the battery for more stable communication, especially if there's huge distances between the ESS and we want to, and there is a condition to have a constant good communications. So we could use the fiber network, fiber options, of course, because the CMU, the smart logger sitting in the cabinet, it has fiber inputs, alternative for fiber communication. And we could actually connect up to 1 to 15 ESS, and fiber networking is completely possible. Yes, about installations, that's also a question which comes a lot to our support service email every day. What are the recommendations? Should this battery be connected to inside, indoor, or outdoor? Especially for Scandinavia, which could get cold outside. So that's also one of the questions we get. Is it possible to have the battery in the cold climate? Of course, this battery is IP class, and it is meant for the very lower temperature, even -20. Because even if it's -20 for our outdoor installations, there is heating system, the AC system, and which maintain the internal temperature of the cells in the battery. So we can have it on outdoor, which is an easy alternative to install the battery. And these are the dimensions of this foundations. But let's say that if we don't have the, say that the battery is very close to sea, where there's too much salt in the air, the pH value of air is like very, the saltiness of the air is too much. It can corrode the battery. So in order to determine, in the manual, it says that the battery shouldn't be closer than 500 meters to the coastline. But this also depends on which water. Like the Baltic is not so much severe when it comes to the salt in the air. But nevertheless, if the installation is closer than 500 meters to the sea, then we should have it indoor. And also we have to calculate the corrosiveness of the air. And here is some, the way how to do it. There's a platform, international standard platform, where we can just put the coordinate of our project, and it will give us the value for the corrosiveness of the air. So if there is up to 4 C4, then we can still use the battery on outdoor. But if it's above C4, then we have to use indoor installations with good ventilation. And this ventilation system also written in the manual, mechanical ventilation system, that the filters should be changed periodically and have very efficient air circulations inside the room you're installing it.
Faisal, one question now. If you are now installing it outdoors and the manual said it's -20
Mhm.
is the like the lowest temperature, but of course we have here sometimes like even -30, but you can still install that outdoors, and will the heaters do the work and the battery will run? Or
Yes, a
if
good questions. I will not, in this respect, I won't say if the battery, because if the recommendation is the lowest temperature is -20, below that temperature it's not recommended to run the battery. But for instance, if you work with the residential Luna batteries, it's the same technology, same material. For residential, if it's -25, the battery will not operate. It will take a lot of time to bring up the temperature, some amount of time. Then after the internal temperature is reached to this operating level, then it will start working. But for this, if it's recommended to install and run it below the -20, which is, for instance, if it's stated in the manual, what happens if you use it? Will it damage the battery? There's a question which I have to actually double check to see exactly if there is anything which might affect the warranty of product if you work it like on the temperatures. But there are always some threshold, some margins. Maybe you don't have like -30 degrees more than 1 or 2 days. So, but we can look into it exactly when it comes to the warranty condition. Will it affect if we have like in -50 degrees?
Yeah, I think that's good, and we can. But I think we are a little bit over our planned time. But
Yeah,
you
I will
can.
just hurry up about here.
Yeah.
Also, if we are making indoor installations for it, then there's this requirements that the fire safety requirement. For instance, the wall surrounding the ASS, it should have a resistance of at least 2 hours if there's a fire. And also the minimum distances between the closest surfaces surrounding the ASS are accordingly. For instance, on the right side, this is the case when we have it indoor installed. So at least there should be 1.2 meters from the closest wall. On the backside of ASS, on the 3 meters from the exterior wall to the closest other buildings. For instance, if there is other buildings in the surrounding. So these are the specifications for the distances for indoor-outdoor installations. Some of these distances could be actually, for instance, the distance in front of the ASS is mostly for the maintenance and to putting the battery and working with the forklift when we are doing the installations. So this distance could be up to 5 meters, but if you don't have a space, you could have like a sort of say fences, which could be open during the maintenance when you're doing maintenance on the battery, and you can close it. So this distance in front of the battery could be actually lower than 5 meters if you don't have a space for it. It's just for the maintenance and putting the battery packs when you're working with the forklift. But other distances, of course, it's just according to the manuals, the closest is 1.2 meters, for instance, or 3 meters from the residential buildings if there's like people living in the other buildings. But nevertheless, so it's always important to check with us if there's any confusions with when it comes to the installation side. Exactly, and 2 meters above the battery, even if it's indoor, you have to have 2 meters according to the manual and the warranty. Is for because the explosive valve, the pressure valve sitting on the top of the battery, so it will open upwards if there's any kind of say explosion in worst scenarios. That will open up. So, and according to Huawei, it should be open up fully. So the minimum distance on top of ASS should be 2 meters. So there are some finished projects in Sweden. I promised Carla to show in order to give you our customers in Finland also a good overview how this battery looks when it's installed. Here we see that the foundation is built from the cement foundations. They had 5 installed battery in parallel. And we have the PCS, the inverter sitting on the left side of these storage systems. Here is more close-up picture of the system. We see on the left side here, we have the communications line between the modules. And also then we have the copper bars in the middle picture between the modules. On the right side, this is the power distributions unit inside the cabinet. So this is how it looks inside the cabinet, and mostly these parts are pre-installed, except these power lines from the bus bar, from DC rack controller, and from the PCS. The customer needs themselves to connect it. Otherwise, the circuit breakers are all pre-installed in the battery, so we don't have to do any work there. Because Kalle asked me also what's the time it takes to install this, the whole system. From our experience, the customer says it takes 1.5 to 2 days to do this work from the moment you're putting the cabinet on the foundations and connecting the whole system. It should be around 2 days work. So when you're doing project design, so it's important you have some estimations of time, how much time it takes to put the battery and connect the whole communications and the wirings.
Is it like 2 days and 2 men, or
2 days, 2
and
men? Yeah, 2 days, 2 men is recommended. Maybe the most time consuming, or at least half of time consuming part is to putting in the modules itself with the forklift, because it needs some kind of careful work to not damage the modules and to use the forklift. So putting the modules takes also sometimes, that's the most time consuming. But other the wiring, the connections, it should go pretty fast. It shouldn't take so much time. So yeah, so this is how it looks on the DC side, the DC rack controller. This is under this picture. We have the magnetic ring too. It should be connected, and it should sit on the right side and on the left side of the DC rack controller. This is the how it looks under the rack controller. You have a bus side and you have the energy battery side. Power lines coming beneath the rack controller, which should be connected by the customer, the installers. And also we have the communications line for the CMU to the out to the smart module from these inputs. SACU, we said that how it looks like inside the SACU. This is this picture. If you can see, my mouse is pointing. This is actually a SACU. But inside the SACU, we have a smart logger 3000. And then we also have a smart module. And basically, these are the 2 things we need for our projects. But then we have also some other units inside SACU, for instance, the over voltage protections and other switches. And also the cabinet itself. So pretty easy to install SACU. But if you only use smart module, smart logger, then you have to build up a cabinet. Even if it's indoor or outdoor, you have to put it in a cabinet, so it's more stable place. Here we have an isolations transformer, which we have used for our pilot project in Prague. And this transformer just sat like some meters away from the ASS. And this project is from Prague. This is our pilot project we did for a while ago. This is one project in Sweden, too, in the south of Sweden. We have one ESS. This is the foundation, how it looks like in the foundations. They had already done the work on the grounding with the EC distribution box. Everything was finished, but even they had to put 2 days to assemble the whole battery. And this is the left side of the battery where the inverter or PCS is sitting. Yeah, the powering on the procedure is also written in the manual. It should be done in certain sequences, but this is also the part that we will provide the service for the putting the system. It has to be configured, programmed when we are after we have done the wiring, everything is finished on the battery. Then there is a need to do the programming on the CMU through smart logger. So there's a lot of programming which needs to be done after the whole system is completed with the wiring when we want to put it up, and before we so we have to do a lot of programming in the smart logger. So this is the procedure how which circuit breakers we will start up with. This is basically exactly how it says in the manual, the procedure, how to use it. For instance, it's also important to know that it's recommended that you don't assemble the modules inside the battery, then you lift up the whole battery on the foundations. First, you put the container, then you put the modules. This is the way which is recommended in the manual. It could be due to the sensitivity of the sensors inside the modules. But yeah, so this is the general way how to do it according to manual. You take the cabinet, then you install the modules once it's on the foundation, not pre-assembling everything and shifting it to the side. It's included one tray, installing tray, where you put the modules and you put it on the forklift to put it inside. So this tray is important to have. So if you make an order with Synergia, or so you have to make sure that this tray is included, or this tray is there because it's needed for the forklift. But of course, if you have several projects, you can use the same device, same tray. You don't have to buy several ones. And also, we had discussion, for example, if there is included any other things. This is, I have highlighted with red what should be prepared by the customers, and it's more about the cabling, some of the communications cable and auxiliary power system cable and the DC power cable. So these are the one which customers will prepare themselves. The communication line from rack controller to the CMU, these are also included. And the power lines are included, but the only thing which customer needs to prepare, these are the one which I have marked in red. This is on the DC rack controller side, by the way, on the right side of the battery cabinet here. Same with the PCS, which will be on the left side of the ESS. So these are the parts which the customer need to prepare themselves. And when installing this PCS, of course, we need torque meter, which have to apply 49 nanometers. There's different torque measures on different part of the battery. For the modules is the different torque. So these are the small details which needs to be taken into account. For instance, the copper bars also need to be adjusted to a certain torque level. And these, if these are some problems with it, then there will be some, for instance, for a warranty. These are the things we will look into when we have to inspect the site, if it is done properly.
Can you, Faisal, Or do you have how many slides left?
That's the last. That's the last. So the
Okay. And I think in this point you can tell a little bit about, because there is some requirements for like that basic service what you provide, and you come to commissioning
yes.
the Luna. So what is what you do there on site, and what part of the installation you come to the site to commissioning and supervising the installation?
Yes, basically we have three different package for our service. It's mandatory that we are on site, that we will do this final checkup of the system, and we will do the programming of the system, and we will put it on the server. So this is something that we have to do from Photomed side or Huawei. This is the basic supervision, where we just come after the whole system is installed, the cabling. We will not do any kind of wiring. The only thing we will do, we will just do some measurements on some power lines, and we will check some insulation resistance on some certain points. And then we will do the programming, which approximately will take 6 hours. So this is what we will do for the basic supervisions. But there's something also called advanced supervision. And there we will do the whole work. The only thing that customers do is to put the cabinet there, the cabinet on the foundations, and then we will install the battery modules. We will do the whole connections inside the battery between the modules. But every works around the battery on the outside, that should be still done by customers' electricians. And of course, then we will proceed with commissioning it, programming the system, putting it on the Fusion Solar. But apart from that, we will also provide some hours of education, training of the system to the customer, the system functionality, or how they can maintain some certain tasks with the container. So we will also provide some hours of education. But before the battery is installed or put on the foundation, we will also try to help with the project design, and also we will help our customers with running a checklist one day before the installations, or sometimes before installation, what should be there, what's missing. We will tell the customers beforehand they put the battery in the foundations. Say that for instance, if the battery will be delivered in 1 week to our customers, before it is on the site, we will try to be on site ourselves and to make a final checkup of the whole system to see that there's nothing missing. It could be about the communications, it could be some about the wirings between the AC distribution box. We will try to eliminate all possible mismatch or anything which is missing before the battery is on site. So that's the advanced part. We will do the electric wiring of the cabinet. We will do the commissioning of the cabinet. We will provide education, training, and also we will be on site 1 day before to check everything is okay with the installation, with the site, before the battery is there. So this is advanced. And we say it is 2 days work. Then also we have like 6 months inspections of the battery, some numbers of times, 12 times I think it is. Every 6 months we will do a commissioning report. We will write a report. We will do a checkup of the system and write the report every 6 months. So this is the advanced part. The basic is just you're doing the software part, basically. We do the commissioning of the system, programming, and we will do also some measurements. Of course, we will see if the bolts and nuts are sitting right. We will do visual inspections. We'll see the wirings, if it's done right. So yes, a combination of mostly visual, then also commissioning part, but no actual physical work on the cabinet.
Okay, but that basic at least is
that's mandatory actually.
required.
But I think basic is the one which we are using a lot in Sweden. The customer is requiring, because even if we are carrying on the basic service, when we have our electricians, installers on site, they learn a lot of things from us when we do the work there. So it could also be like a learning process for them when they are with us there. Other than that, I think basic is, it's good enough. Even in basic service, we will provide like a full, complete report of the installations. We will write a report, now we will sign it if it's okay with the installation. And every 6 months, we will do a controller checkup of the system remotely and provide a report to our customers, even the basic.
Okay. But
1 day for
now,
basic is meant and 2 days for advanced.
Okay. But onko nyt tässä vaiheessa jotain kysymyksiä, niin ne voi kirjoittaa tai sitten olla tarvittaessa myöhemmin yhteydessä. Voi laittaa vaikka mulle sähköpostia suoraan tai soittaa. Niin katsotaan niihin vastauksia. And I think we are Faisal. I ask if there's some questions and say that the participant can contact directly me, and then we can figure it out the questions. But
of course, if it's needed, we could share some of this material with them.
Yeah,
with the participants.
I write that you make some kind of like not maybe all, but some short version of this presentation, and we can share that.
Yes. So the main point, I will just summarize it in 2 sentences. I will not take more time. SACU, you have options. Instead of SACU, you could only use smart logger and smart model, those 2 units. You can have this battery both on indoor or outdoor, but you have to do those kind of calculations for the air quality and those distances. So these are the 2 main points. And of course, the system flexibility, we talked about the isolation transformer when it's needed. So these are basically the main points from this presentation. If you have any questions, all the participants, please, Kale can share my email address with you guys. So feel free to contact me by email if there's anything we have missed today or if it's misunderstood, we can try to answer it.
Yeah.
Other than that, I have nothing more to add.
Okay.
Sorry for extending the time.
Yeah, thank you Faisal for the presentation, and kiitos osallistujille, ja tosiaan tästä tulee nauhoite tuonne YouTubeen ja laitetaan esitystä jakoon, mutta kiitos tästä ja ollaan yhteydessä. Thank you and have a nice day.
Thank you. Bye, Kalle. Bye, everyone.